Okay, had some questions come in. I think sure I didn't do anything new. 110, got a few questions. These are my questions. I need to read those. No, y'all in the class. All right. Review 2, review 1. This is review 1 and number 29 in the book, number 3 online. Find the product. Okay, so product means you're doing what? Multiplying. Oh, y'all are awake this morning, aren't you? Oh, I hear you. Let's go to transparency. And let's use the FOIL method probably. So 4s minus 1. See, isn't that nice? 5s plus 3. You don't have to wait 2 or 3 seconds. And use your FOIL method. That's going to be 20s squared. Outer, or not from around here, outside plus 12s. Inside minus 5s. And last, minus 3. These two guys will usually, 75% of the time, they'll usually what? Combine. And you got $12 minus $5, that's what, $7. So 20s squared plus 7s, check 12 and 5. I think that's 7, isn't it? Yeah. Because I can't subtract 5 very well. 3. Yeah, it should be, right? That must be the wrong one. Let's see what happens. Type in the right answer. Huh? Yeah, I hope I didn't do it wrong. If I did, then I'll just be unsure of myself. All right, stacks on the truck. 20s squared plus 7s minus 3. Good job. I saved myself from going into depression. Everybody got that one? So that one you use your FOIL method or the distributive law. You use distributive law, it's the same thing. Okay. Next one. That was R1. This is R2 and R3. So R2 comes first. Or we might have done this one. I can't remember if I did it or not. Let's see. We did that one last week, didn't we? What was that? Oh, yeah, we did that one. I thought somebody was cracking their neck or something. Anyway, we did that one. R3, 11 and 63. R3. Okay. Write the rational expression in lowest terms. So they want you to write it in lowest terms. So do it. Anytime they want you to do anything with a rational expression, the first thing you're going to try to do is factor. Always remember that. Write it down. If you're going to do anything with a rational term, usually you're going to have to factor first. Well, what's the only thing you can do here? What's the only thing you can do here? Factor out a common term, Hubert. Thank you, class. Thank you for the interaction. What can come out of 3y minus 12? It leaves you with y minus 4. What can come out of the bottom? 5. Well, that leaves y minus 4. What happens to y minus 4 with y minus 4? You left it 3/5. 90% of the time, when you're dealing with rational expressions, you're going to have to factor sometime, somewhere. Let's uplift ourselves and type in 3/5. It won't let me. We feel good about ourselves. Next one. That was R3. This is R363. Oh yeah, we did this one the other day, didn't we? Okay. So that takes care of the homework questions. Anybody got any other homework questions? All right, then let's see what we got in the class to do today. Let's go to our handy dandy Pearson. Let's see. What's that? Back up. Go to courses. Go to 110. Go away. So we need to start class today, correct? Because y'all went over the review, so we're ready to go into which chapter we start with. 1. Somebody look in your multimedia e-text. Should be parent graphs, transformations. As soon as I look at the chapter, that's what we'll do. That's why I was pulling up that. Is it chapter 1? Somebody look. Okay, nobody's going to look. Huh? I'm sorry. What does the outline say? We start with chapter 1 after the review of intermediate algebra. Should be at the top. Now this is program outcomes. There's not an outline at the end I gave y'all. I thought there was. No, it's the last page. We didn't include it in the syllabus. No, they didn't. Sometimes they do everything backwards. That means I got to go to. I'll hold up a minute. Now, this is what they're doing. They're taking the last 2 pages of the syllabus off the syllabus, and they're putting it somewhere totally different. Okay, nice. Yeah, great idea. Take part of the syllabus and go hide it somewhere. So let me go. It's on Blackboard. I'm sorry. Hold on.
It is amazing how different it is. I've taken several online classes, and still, every class, it's like it's a little different. Because I missed an assignment because the teacher put it in the discussion board. You know, and I didn't want to argue with it. I'm not going to start a special argument. It's like, are you kidding me? You put an assignment in the discussion board?
Yeah. Well, the reason they have to do that is for the objectives. You have to put something in the discussion board. I got fussed at because I didn't do it. I said, that's stupid. If people go to the discussion board, they're going to go to the discussion board. You ain't going to force them to go to the discussion board. But they believe.
It's like it is to get simplified.
Yeah. And how's the best way to simplify it? Take 2 pages off the syllabus and go put it somewhere else. I thought it was still on the syllabus. I'm sorry. Course outline. I'll save it and hopefully send it to you. There it is. All right, write these down. Relations and functions, 1.2, 2.1. We're going to go through 2.6. All right, 1.2, then 2.1 through 2.6. I'll save this. Save as my documents. Math 110, and I'll send that to y'all at the end of class. Relations and functions. There we go. All right. Sorry about that. There's one more I need to pull up because it said functions. Did it say functions? I think it did. I'm looking for functions. Oh yeah, it messed up. Okay. There's too many functions. Nope, that's not it. I've got one section that's got like 5. I don't know why I can't. Size. Functions. Which one's the biggest function? It's not. I guess that's the biggest one. Yeah, that looks better. 16 slides. All right, slide sheet. Is it showing up? There we go. Sorry about that. What do all of these things have in common? Well, the first is a ice machine, the second is a hay baler, the third is a bicycle, and the fourth is an expression. All of them have one thing in common. They're all functions. When we're talking about a function, we're talking about something that does something. The ice machine makes ice. The hay baler makes hay bales. The bicycle makes motion, or makes whatever. It makes you go. All right. I'm not a physics teacher. And the expression makes X turn into Y, just like leg power turned into movement, grass turned into hay, and water turned into ice. Now, I might have shown y'all this last week. I don't know if I've shown y'all this or not. But all of these things on the left are input. And all the things on the right are output. Now, what makes this unique? Well, what depends on what? Tell me what depends on what? Output depends on input. Now, that's too redneck. So you got to say the R word depends on the D word. Okay? So let's say it. The range depends on the domain. You got to sound sophisticated. All right? What does that mean? Well, if I put 5 gallons of Kool-Aid, water and Kool-Aid, 5-gallon bucket. And on the farm, everything's by 5-gallon bucket. You know why? Because that's what all the hydraulic fluid comes in. It comes in 5-gallon buckets. So after you get through with the 5-gallon bucket, you take the top off. I mean, the 5-gallon container. You take the top off of it, and you use it as a 5-gallon bucket. You wash it out, and rinse it out, and everything, and you feed out of it, and everything's in 5-gallon buckets. You don't have 2.5-gallon buckets on the farm because nothing comes in 2.5 gallons. All right, you don't recycle stuff. So anyway, everything's in 5-gallon bucket. So you got a 5-gallon bucket of orange Kool-Aid. No, let's make it cherry Kool-Aid. And you put a funnel on that water line. I know all of you know what a funnel is. You all graduated high school, so all of you know what a funnel is. You put the funnel in the water pipe. You put that 5 gallons of cherry Kool-Aid in the ice machine. How much ice you gonna get out of it? Cherry ice. How much cherry ice you gonna get out of it? You should get 5 gallons. In other words, that ice should fit. Well, it's probably not gonna fit in that 5 gallons, but it's 5 gallons worth. It's not 6 gallons. It's not 3 gallons. It's 5 gallons worth. Now, of course, there's some that's probably left in the ice machine. You're not gonna get exactly 5 gallons, but you understand what I'm saying. You're not gonna get 8 gallons. You're not gonna get 3 gallons. You're gonna get around 5 gallons. If you put 10 gallons of grape Kool-Aid into the ice machine, you're going to get 10 gallons of grape ice, whatever you call it, coming out of it. You're not going to get 12, you're not going to get 8. Everything depends on the domain. Everything. The grass. If you cut 5 acres of grass, you're going to get 5 acres of hay. Okay? If you get one round bale to an acre, you're going to get 5 bales of hay out of that 5 acres. 1 bale to an acre is pretty breaking even, all right? Anything above 1 bale an acre, you're doing great. Anything below 1 bale an acre, you suck, all right? Legs, all right? I don't mean this, I told you that. I feel like I've gone over this lesson before. It might have been for the...
You briefly mentioned it.
Okay.
You didn't look at the PowerPoint.
Okay, good. Well, that's the leg thing. If you have 2 broken legs and you are in cast, if you get on that bicycle, what's going to happen? You're going to fall down. All right. I had to put the broken legs in there because I said if you have no legs and you fall down, and people say I have kidney. So I had to make them broken and put in a cast. All right. You've got to have leg power to move or arm power to move a bicycle, or the function does not work. Same thing with this. That is a function. It's just like a hay baler. It's just like all these things above. You put something in it, you get something out of it. What you put in it, you get out of it. Range is dependent upon the domain. The only thing that affects the domain is the teacher or the directions or the problem. Okay? I'm sorry, I have to. On my computer, I hit the enter button, and this computer, you have to do this. Sorry. Okay. What happened? I guess I'm. Okay, I'm supposed to have something happen here. I don't know what's happening. Okay, let's see, on my PowerPoint, I can go and I can go right to the, okay. How do we write domain and range? When you're dealing with these 2 guys, you have to worry about open circles and parentheses. When you're talking about these 2 guys, you got to worry about closed circles and brackets. So if you had Math 102, you remember that. If you don't, then you need to write that down. Set builder notation. I had all this. I don't know why this is not showing up, so maybe because of this, I don't know. But it's not showing up the way it's going to the next, and this is not right. I don't even know why that's there. And my numbers are not coming in. Something's not working right on this PowerPoint, and I don't know why. So anyway, sorry. So if I want to write the domain is x greater than 3, then that's going to be x such that x is greater than 3, and I would put, if I was going to write that in interval notation, I would use parentheses. That's set builder notation. If x such that x is greater than 3. That's set builder notation. If I was going to write x such that x is less than -5, that's set builder notation. And it was supposed to show a picture over here. So I'm just going to draw a line. If I've got a line going from here, and it's going that way, then my domain is from 0 to what? Infinity. So in that line right there, if I was to write that interval notation, it would be 0 to infinity. Now infinity always gets a parenthesis because why? You can't ever touch infinity. So it always gets a parenthesis. The 0 is inclusive because it's a closed dot. So it's a bracket. Okay. Hopefully, if you've had Math 102, you know the difference between interval notation and set builder notation. Most of the time, I use interval notation. Most of the time. Okay. Question. Okay, now it's frozen. Okay, I don't know what happened here, but it's supposed to have little numbers come up here, and it's not, and I don't know what to do about it. So there they are. And I don't know what happened over here. So there's your numbers, and we're talking about this function that I showed you a while ago. You plug those numbers in, you get what? Now, who set these numbers up? I did. Do you have to use -2 to +2? Well, if I specify in the directions, you have to use -2 to +2. Then yes, I have set the domain, so therefore the domain is affected, the range is affected. If I say use any numbers you want to, then this function is all real numbers. The domain is all real numbers, which means you can use any number there, and the range is from 0 to infinity or whatever it comes out to be. What does that say? I'm sorry. That's bugging me. I'm sorry. I don't know why that's even there. The numbers in yellow, see these, there's supposed to be a graph here. There's no graph. So, and I don't know what happened. These numbers right here represent these numbers right here, and these numbers right here represent the range. Okay? I don't know why that happened. And this function and that function, we'll do this function. Plug those numbers in, and you see that again the domain is still -2 to +2. So therefore this function is a parabola. It's got a y-intercept of 4. So I'm going to draw the parabola as soon as I can find my handy dandy whiteboard again. I'm not used to these PowerPoints acting the way they're acting. That's what's wrong. I'm sorry, but I'm not used to the way this computer uses PowerPoint and my computer at home uses PowerPoint. There's supposed to be a graph show up over here, and it's not showing up. Something missing. So -2, +4. -2, +4. -1, +3. 0, 4. 1, 7. And 2, 12 is way up there, so this one's going to be 7 right here. And you see the parabola looks like this. Now, since I have not told you that the domain is -2 to +2, you see that the domain is all real numbers. domain is equal to all real numbers. Why? Because of these two guys right here. They basically, I'm being exaggerative here, but they basically keep going. And all the x's are taken in to this function. In other words, you can plug in any number to this function, and it's going to work. Any number. You can plug in a positive, you can plug in a negative, you can plug in a fraction, you can plug in a decimal. Doesn't matter. So, what about the range? Well, the range is not all real numbers because the function doesn't start until you get to where? 3. So that's where it takes off. So 3, the range is equal to 3 to infinity. And 3 is inclusive, so it gets a bracket. Can we use any number for this x? Yes. So the domain is not affected. Okay. Question? Right, complaint. See, on my home computer, all I hit is enter, and it keeps on going. So, okay, I just used cursor. There we go. Now do this one. I want you to do this one. And I think we might have done this. I can't remember if we've done a radical or not. Why did I pick 2? And that's not supposed to be a 4. That's an error. That's supposed to be 0. Because what's 2 minus 2? That's supposed to be 0. So plot those points. And I want you to write down the domain and range for this function. No sneezing in class. Okay, I'm going to throw you out. Okay, so this function, can you put any number in this function? No. What numbers can you not put in this function? Good, so that means the domain is from 2 to what? Yes. And you can look at the graph, plot the points, 2 and 0, 3 and 1, 4 and 1.4, 5 and 1.7, 6 and 2, 8 So your domain is from 2 to what? 2 to infinity. Okay? The range is from 0 to what? What does that mean? It means it continues slowly, but it continues to keep going up. So that means from 0 to what? So the domain is affected on this problem because it's a radical. Notice, radical, there's a problem. Rational, there's a problem. Anytime you see a radical or rational, your domain is going to be affected. Capiche? I understand. And there is your rational. I think we went over this because I explained to you that it would leave what right here? An open what in the graph? Or it would be vertical asymptote. And I think we went over that. I'm not going to go over that again. Okay? And we talked about, I think I ran out of slide. I think that's what happened. Now, since pre-algebra and algebra 1 and algebra 2, you've been told how to add, subtract, multiply, and divide polynomials. Well, now you're not going to be told to do that. You're going to be told to combine functions. Okay? Hold your pinky up because you got to do it a different way. You were told to multiply, divide, substitute. You were told to do that in algebra 1 and algebra 2. Now it's going to be called something different. Now you're going to be called functions. Instead of y being in front of the equation, there will be an f of x. And it'll look like that instead of this. This is the redneck way. This is your fancy way. And that's the only difference. Instead of y is equal to 3x plus 4, it will be f of x is equal to 3x plus 4. So f of x is a fancy way of writing what? Y. Of course, people will disagree with me. Now here are the ways that you're going to see it written. The way that you wrote, combine the polynomials. That's what you used to see in pre-algebra. Now you're going to see f plus g of x, f minus g of x. I'm serious. There's no difference. In pre-algebra, the direction said add or subtract. Now, you're not supposed to do the redneck way. You're supposed to do f of x is equal to x plus 4 and g of x is equal to x minus 3. Find f plus g of x. And guess what? It's the same exact thing that you did back in pre-algebra. Except now, you got to hold your pinky up when you say it. F plus g of x. Okay? Remember doing the multiplication problem with the FOIL method? Well, now it's going to be f of x is equal to x plus 2, g of x is equal to x plus 3. Find f times g of x. And this is the same thing you do now. What I'm trying to say is when you're talking about functions, you're not talking about something new that you know how to do. It's the same thing that you learned how to do back in pre-algebra.
Well, they use G.
Comes after F, I guess. I don't know. I don't. H, I, J, or A, B, C, D, E, F, G, H, E, F, G. That's fine.
Just the
yeah. Sometimes they use H of X. Sometimes they use G of X. H of X, G of X, and F of X are usually the most used. Here, remember dividing this? Well, now it's going to be f of x is equal to x squared plus 2x. G of x is equal to x. Find f divided by g. Like I said, nothing different. Here, they told you to substitute. So y is equal to 2x plus 3. So where there's a y, you plug in 2x plus 3 and do the math. They're going to do the same thing, except it's going to be a little bit different. Here's what they're going to do. They're going to give you functions. We see f composed of g. I call that fog. And then I call this golf. All right, fog, golf. They give you f of x. When you see f composed of g, f composed of g means that you're going to rewrite f. And wherever there's an x, you're going to put a big set of parentheses. Okay? And if it says f composed of g, you're going to say f. Okay? I'm going to rewrite f with a big set of parentheses. And wherever there's a big set of parentheses, I'm going to plug in g. And that's what I did here. F composed of g. So I take 2, I rewrite this, 2 big set of parentheses plus 3. And what I do with x plus 7? I plug it back in. And that gives me the blah, 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 gives me 2x plus 17. Golf, I'm going to rewrite g with a big set of parentheses and plug in what? Okay. This is where you need to get your own little system down. My system is, what letter comes first, I rewrite that equation with big parentheses. So here, I rewrote this with a big set of parentheses. Here, I rewrote this with a big set of parentheses. Well, what about f composed of f? Fog. Okay? F composed of f, I'm going to rewrite. I'm going to write f with a big set of parentheses. And what am I going to plug in it? F. G composed of g, I'm going to rewrite x plus 7 with a big set of parentheses. And I'm going to plug x plus 7 in there. Whichever letter is first, you rewrite that function with a big set of parentheses. And then you plug in what the other letter is. Simple as that. This right here is one of the biggest problems with functions students have, is composition. You've got to find your own little method of doing it. And I have found that this little method works because this is what I used when I was in college algebra. Whatever letter comes first, you rewrite that equation with a big set of parentheses. Now, something you might do is you might highlight those parentheses, and then you might highlight the other letter so you can remember to plug that into the big set of parentheses. You may do it with highlighters. I don't know how you're going to do it, but that's how you do it. And again, this is taught in 102, so this is kind of a review. Okay? Now, what's not a review? Well, the other one. Parent transformations. Whatever, just go back to that one thing. Okay? Now, this is today's lesson, because I think we reviewed over the other one. So let's go with, where's my, okay, I'm trying to find, I want to present it. Where is, I'm sorry, this is just a different way of doing things, and I'm not used to it. I don't want to do that. Okay, slideshow. I don't know why. This is totally different from my computer at home, I'm sorry. Now, get your piece of paper out, preferably graph paper, take your straight edge, and I want you to draw, put it in landscape, and I want you to draw one line across and 3 lines down, so you'll have 8 sections, because you're going to draw these guys. These are called the parent graphs, also called family of graphs. Write them down. Like I say, I don't know if I went over this with y'all or not. Okay. So we're actually starting college algebra today. And draw 3 lines down, and you're going to draw these little graphs. And we're going to go through them and talk about them. And then we're going to talk about transition. First one is called a linear function, and that's when x is raised to the first power. The nonlinear function, and so on. Take a minute and write those down. That quarterback from the San Francisco 49ers, is he very smart? Huh? I think he's pretty stupid. Well, nobody heard of him until he did that, and I guess that may be why he's doing it, because nobody's heard of him. I haven't heard of him. And from what people have told me, he's like second or third string, is he? Nobody knows. Okay. Huh? He's the backup, so he's second string at least. Maybe that's why. Maybe he did it on purpose so people will know him. I think, but he sure did pick a sorry way to get publicity. He didn't stand for the national anthem, and he said that he didn't stand for the national anthem because it oppresses black people and it's racist. Coming from a man that makes millions of dollars in the NFL.
Yeah.
Oh, I'm sorry, 19 million. Gotta love that capitalistic society that's protected by, you know. Yeah, I know he's really, and to make it so sad is he's adopted, and guess what color his parents are? White. He's black, and he's got white parents because he was adopted. But America is racist.
Yeah, and he's in like the 0.0005% of people in the country.
Yeah.
And it's just, you're the exception to every rule, but you're doing that wrong.
And he was fined. When was he fined for using the N-word? He was fined by the NFL for using the N-word. Where do these people live? Do they live where the unicorns and the chocolate mountains are? Where?
They live on Facebook and seeing
Tell you what. Okay. Now, I want you to make sure before we go on, when you come back Wednesday, make sure these are in your head. Okay? They need to be branded in your brain. These are the basic models. When you go buy a car, what determines whether you buy that car or not? Well, before gas mileage was a concern, it was what? The luxury items, right? Some people, if you're going to, okay, let's say you own a business and you got 2 or 3 crews that go out. Are you going to buy a Cadillac, Fleetwood Cadillac for each one of those people? No. Or are you going to buy a stripped down white Ford pickup truck that might have a radio and might have air conditioning? That's what you're going to buy. You're going to buy the stripped down Sally, all right? The one that has nothing, doesn't even have carpet. It's got that vinyl stuff on the floor.
You spray it out.
Yeah. So what are these guys? These are your stripped down Sallys. They don't have power doors, power locks, heated seats, the little video, what do you call them things, DVD players in the back seat for the kids. These are the stripped down Sallys. Now, what do you compare everything to in the car world? To the stripped down Sallys. All right, you can get a Mustang that has nothing in it but a radio and a V6 engine, all right, with a air conditioner versus a, well, let's go with the Dodge Charger, okay? The Dodge Charger, because I think it looks better. The Dodge Charger with an air conditioner and a radio versus a Hellcat. And what's a Hellcat? It's pretty bad. I mean, I'm not a car guy, but if I wanted a car, it would be the Hellcat. Yeah, I mean, they say it's like 800 horsepower. I mean, I'm sorry, I'm awful confused. Yeah, it's more than 600. It's more than a V6, all right? Okay. But if I was going to buy a car, it would be a Hellcat. I'm a truck guy, so I buy trucks. Well, I don't buy trucks. Right now, mine's a tank. So. And I'm driving around my mother's Mountaineer, and it smells like dogs. She knows I can't stand that, so I'm going to go get it washed today. I can't stand dogs. Anyway, she got 2 dogs that drive around in the car with her. Anyway, my mother's, she's disappointed. Anyway, she don't know why she don't have cats. Anyway, to make a long story short, these are your basic models. These are your Challengers or your Chargers or your Mustangs or your pickup trucks with the air conditioner and the AM/FM radio. That's it. Okay? Everything that you're going to compare to these guys are going to be compared to the basic model. And they're called transformations and orientation. So when I throw up x squared function, we're going to, by the time we get through with this section, you're going to be able to tell just by looking at it what it's doing compared to the second function, since I said x squared function. If I give you a square root function, you're going to compare it to the square root function. If I give you a absolute value function, you're going to be comparing it to this function right here, the basic model of that series. That's why I use Charger, Challenger, Mustang, F-150. I'm not going to compare an F-150 to a Mustang in any shape or form. So that would be like comparing an x squared to this guy right here. I'm not going to do that. But I'm going to compare all the Chargers or all the Mustangs. I'm going to compare the absolute value function I give you to this guy. I'm going to compare the x squared plus 4x plus 4 to that guy. I'm not going to compare it to this, because that would be comparing an F-150 to a Charger. They're the 2 different animals. Okay? Now, how many of you had college algebra before? Anybody? Okay. Okay. I'm going to ask you a question after this, because this is a section that people usually get kind of confused at. I'm going to ask you, because I hope it's not confusing. But anyway, here's now you see what this is doing? This is pissing me off, because my PowerPoints are not screwed up. And now I've got y is equal to x squared in the middle of my PowerPoint. All right, so I'm going to start with the x squared function, okay? And everything we're going to do for these first few slides is going to be with the x squared function. So I want you to graph on a piece of graph paper And just make it a big graph because, in other words, draw a line down the middle of the graph paper and across. And I want you to draw f of x is equal to x squared on your graph paper. Do it in a black color, like a black or a pencil or a dark color, because that's your basic model. Y is equal to x squared. And just pick -2, -1, 0, 1, and 2. And graph those points. Because the next one, we're going to do, well, I'll go ahead and draw this function for you. There we go. There's that function. Now you're going to draw several graphs on this graph. So you want to make it, and that's why I told you to bring colored pencils. You got pens or highlighters, get them out, use those. Because I'm going to use different colors on this. There's your first function. And you don't have to draw them going off the whole point of this slide is to show you what the A value does. This A is the coefficient in front of the x squared. Yeah, I had to take my truck up there last night because I had an 8 o'clock this morning, so I was in the parking lot of the Mako place up there taking my lights out of the back and my lights off the fender, so I guess I'm surprised the sheriff's department didn't pull over and think I was breaking into the place. But I just had got that new bed and those lights, I figured I'd take them off so they wouldn't have to tape it out. I can't stand when somebody tapes out something, especially a white bed, and they paint it and they leave little places where the tape is not covered and the white just shines. So that's why I took the lights out. I didn't want them to mess it up. I'm weird. After you graph that function, graph this function. Y is equal to 2x squared. So the A has changed from 1 to 2. And watch what happens. And do it in a different color or a highlighter so you can see the difference. And what did you notice when you graphed it?
Sharper.
This more narrow. Now, the way you would say that, of course, you can't say narrow. You can't say skinny because that would make sense. So we have to think of a way to confuse people. So what we'll do is we'll take our handy dandy line maker. Well, I wanted to draw but you're being pushed this way. In other words, compared to the black function, you're being pushed along the x-axis. Now this pushed is you can't call it pushed. You got to call it something different. Compressed.
Constrained.
Yeah, compressed. It's being compressed along what axis? No, the x-axis. In other words, think of a set of vise on your vise in your shop. Okay, you got a vise. The jaws go horizontal. Okay, so they're going along the x-axis. Think of a balloon being pushed by your hands. What's going to happen when you push this way. Which way is that balloon going to go? It's going to elongate. It's going to get skinny. Same thing with this guy. All right. So what is the red graph doing compared to the black graph? It is being compressed along the x-axis, but it's being stretched along the what? Just like a rubber band. When you stretch a rubber band, what does it do? It gets skinnier and it elongates. So instead of saying it gets skinny, you've got to say the function is compressed along the y-x-axis and is stretched or elongated along the y-axis. That's what you got to say. Okay? Next one. You do this one. 1/2. Now the a has turned into a fraction. See what happens now. So that way you're going to use multiples of the what? To keep it simple, you're going to use multiples of the denominator. -4, -2, 0, 2, and 4, because you want to clear the what? The fraction. So you use multiples of the denominator. Kaepernick, what's his name? Kaepernick, whatever his name is, says he doesn't care if he loses his sponsors or gets cut from the team. Guy's an idiot.
Yeah, the problem is athletes don't get people killed, let's say.
Yeah.
We just want to see your performance.
The celebrities, yeah.
We don't care what you think.
Yeah, the celebrities think that too. All these celebrities that say, I'm going to leave if Trump becomes president. Don't let the door hit you in the butt, but they're not going anywhere. Why? They're making too much money in the capitalistic society of the United States. They're the biggest bunch of hypocrites that ever walked the face of the earth. Celebrities. Then I think right below celebrities you got the athletes. To sit there and, you know, there's old saying, you don't bite the hand that what? That's a very true statement. And I have done boycotted, and one of my most favorite actors, I love him to death, is Will Smith. But I'm not watching him no more. After he said what he said, if you have an opinion that differs from him, you need to be cleansed. You know the last person to use the word cleanse? Anybody? Adolf Hitler. I can't believe he used that. I mean, I always thought he was a classy guy, but we need to be cleansed if we differ from his opinion. So, no more of his movies. And I hate it because I like him. They just need to shut up. Support who you want, but don't say. And then they have the audacity. Okay, if you disagree with Will Smith, you should be cleansed because you should not vote for a bigot. He used the word bigot. What's a bigot? Anybody know the difference? I asked my son. I said, Walt, do you know what the term bigot means? He said, yeah, it means you're getting large or fat. I said, yep. Somebody tell me the definition of bigot. If you differ from somebody's opinion, and your opinion is it, if it's your opinion or no opinion. Will Smith said, I'm quoting him, he said, if you don't agree with the Democratic Party, you should be cleansed and not vote for a bigot like Trump. Now think about that sentence. If you don't agree with the Democratic Party, you should be cleansed. What is that called? A bigot. Unicorns and pink skies and chocolate mountains. Yeah. That's just, and to see that come out of his mouth was just so disappointing. I could see it coming out of like Rosie O'Donnell's mouth. I mean, she's. Anyway, I'll shut up. All right, here we go. What'd you find out? It's not wider. You can't say wider. You're redneck. You can't say that.
It's less compressed.
Oh, that's even worse. It's bigot. It's bigoted. It's gotten bigger. What's it? It's being what? Stretched along the x-axis and what? Compressed. Compressed along the y-axis.
Well, at what point does it? Because like a 45, I guess that's the perfect balance of the two, right?
Well, that's a straight line.
Okay. I guess at what point it'll have to hit at some point where it's kind of
that's the black line. The black is the basic. Well, that's the basic model.
I mean, okay.
You see what I'm saying?
Yeah.
The 45-degree angle, the 45-degree line, that's the basic model for the line, the straight line.
Right, yeah.
So anything compared to it would be either shallow or steep.
Okay.
And the A, the coefficient before the variable, tells you what kind of orientation you got. Whether it's compressed or fatter or skinnier. Or compressed along the x-axis or compressed along the y-axis. Or stretched upon the x-axis. Just remember the balloon. What is the balloon doing? All right, in this case, the balloon is being what? It's being stretched along the x-axis to make it wider, or you could say what? It's being compressed along the y-axis. Stretched along the x-axis, compressed along the y-axis, that's the same thing.
You can say either one.
You can say either one. But they're going to ask you both. I'm just telling you.
And those are both hitting the origin because there's not a second variable.
Yes. Right. Mm-hmm. Okay, now we're going to get into the second variable in just a minute. You're stealing my thunder. Can I be in charge for a while? All right, so let's do our last one. -2. Well, the negative in front of the 2 is just like this one, only it's going to be going what? It's going to be going in the opposite direction. Oops, sorry, I messed up. There we go. So is the red line and the magenta line the same graph? Yes, it's the same exact graph, only it's going in what? Opposite direction. Positive and negative in math and science and business tell you what? Direction. If you got a negative $200 balance in your bank account, that means it's below zero. Okay?
You're going down into the ditch.
Yep, and you're on your way to living in the ditch, in a cardboard box. All right, next one. So, look at that one. You can draw this one on your graph too. I just went to a different one because it was getting a little bit cluttered. Draw this one. So, can everybody ascertain that if you have a letter, a number in front of your variable, that tells you what? It tells you the orientation. Yes, the orientation. This guy is going to tell us something else. Look at your graph after you graph it and tell me what it does from the black graph or the X squared graph. And you come up with a graph that looks like that. And that graph, compared to this graph, has a vertical shift of what? 4 spaces. So when the number is not attached to the x and is outside the square, that is k, which is a vertical what? Vertical shift. It's very important that you understand where that is. It is outside the square. Anything inside the square, it'll have parentheses and it'll be something else. I'm sorry, I forgot to do that.
So the variable with the exponent, what does that change? Like
Doesn't. It is x squared. That's the basic model.
Okay.
It just moved down 4 places.
So 4x squared.
4x squared is going to be skinny.
Okay, it's just, okay. Gotcha.
The number in front of it tells you it's going to be skinny or wide or going the opposite direction. All right, here's another function. You can graph that, and you'll see something else. Well, you can pretty much deduce that if we've done orientation, horizontal shift, you can pretty much deduce what the positive 2 is going to tell you. What is that? The what shift? The horizontal shift, and this would go to the left. Now, it's the only time that you're going to see in mathematics a positive 2 being left. I've got to do my dots as soon as it comes up. I'm waiting for my dots to come up. Well, there we go. There's your parabola, and from the basic model, what's the horizontal shift? 2 to the left, and what's the vertical shift? 4 down. Notice from the previous that the 4 is outside the exponent, so it's a vertical shift. But the 2 is what? Inside the exponent, and it's attached to this x. If it's attached to the x, that means it's the horizontal what? Shift. Now the horizontal shift is always the opposite direction due to the x minus h property. The original property is x minus h. But to get this to come out to be a positive, it would be x minus a negative h, or x minus a negative 2. So negative 2 means what? To the left. So to get the x plus 2 to look like the original property, x minus h, we'd have to change this to x minus a negative 2. And negative 2 means to the left. But x minus a negative 2 is what? X plus 2. So you can say that it's the opposite. I usually don't show this because it confuses people.
Yeah, that's confusing.
So just to do the opposite. I'm sorry, I got to do my leader lines. There's my horizontal shift, and I'll throw that in there for y'all. Okay? So, whenever you see a quadratic, it's usually written like this. Oops, sorry. I can't write. Okay, I'm not going to go through that. So, ax squared plus bx plus c is equal to 0. Now, we're going to do something in the future called completing the square. And completing the square is going to turn this into what? That. It's called the intercept form. And when you get it in the intercept form, what does the A tell you? It tells you orientation. It tells you if it's wide. It tells you if it's skinny. It tells you if it's normal. It tells you if it's opening and up in the other direction. The H is going to tell us what? The horizontal shift. And the K is going to tell us the what? H and K gives you the vertex. Now, when we get to completing the square, you're going to see that there's two ways to write the answer. One is in intercept form, like this. Oops. This is intercept form. And the other is general form, like that. And we'll get to that when we get to completing the square. Question. Now, can you apply this to the other parent graphs? Yes. Watch. What is that? Dot parentheses is what? So this one's going to be compared to the absolute value V. The black V going in a 45-degree angle both ways. There's the black V. Now, what does this negative tell us? Negative 4 tells us it's going to shift down 4. This is going to move over to the left. And it's going to be what? Wide or skinny? Skinny. Ain't that neat? So what I'm trying to get you to learn in this first unit or first section is how you can look at something and be able to tell which direction it's going and which vertical horizontal shift it is, and if it's skinny or if it's wide or if it's opening up or down. And remember to say compressed along the x-axis or y-axis, stretched along the y-axis or the x-axis. Can you do this one? It's cubic function. Yep, basic model looks like that. So what does that mean? It means we're going to move over, forward to the left, and what? I'm sorry, 4 down, and what? So it should be right here. Notice it's a little bit compressed. I messed that up right there. Don't look at that. But it's compressed. This is not as shallow as this. It's being compressed or stretched along the y-axis. Okay? So that's your parent graphs and transformations. So let's look at some of your homework questions. So you can feel good about yourself. Right? That's all that's important, right?
Yeah.
So you don't have to put smokestacks in your truck. Hell no. No. Well, I can get more horsepower out of my engine, right?
Yeah, always.
Yeah. That's what they. And what?
Water.
Well, yeah. I'm not gonna say a word. I've actually heard people say that. Don't even get me started. Study plan 1.1. Let's see how you do. I'm waiting for you. Where you at? Come on, study plan. Okay, we don't have the study plan anymore, or what? I'll throw that away. I'll throw that away. I'm looking for the study plan. Hello, study plan. Come on, study plan. Okay, there isn't a study plan anymore.
Pretty sure we started 1.2.
Huh?
Didn't we start?
Yeah, 1.2. Doesn't matter. I can't get the study plan to come up. I'll just go to the homework. Thank you, though. What the heck is this?
Technical issues. Bam.
You are kidding me.
There wouldn't let me, I haven't been able to get in on the.
Yeah.
It's been working for me just to say this, I thought it was going to a week and a half. When I first got called.
Okay. All right.
I better fix that tonight.
Yeah, 1.3. So let me get the roll. I didn't know. What time's class over?
Whatever.
Okay, I got 1 minute. No, I got 1 minute. The computer says 1 minute. So. I got to get the roll, because if I don't get the roll, then y'all get the nasty bureaucratic email. And I don't want you getting that, because then you'll be emailing me.
I've never even got it. I've been late,
Well, it's a miracle.
Oh, they got me on the online thing.
They got
kicked
you.
Me, they kicked me out of the class the first week. I was like, you gotta have 2 absences.
But they're cracking down.
That was because I missed that discussion question.
They're cracking down on it. Be
Yeah.
assured, the federal government's cracking down on these people. Let's see, we got 3,000 students. I think there's like maybe 1 student they're cracking down on.
Yeah.
Ellis,
Here.
Grant, Hall, Karki,
Here.
Lindsay, Rusnick,
Here.
Saab came by, C's here, and Skipper. All right. Y'all are responsible for 1.1 and 1.2 homework, if it ever comes up. Y'all have a good day.
Can you help me?
No, I'm off the clock.
Sorry. I want to do my work. I feel like I'm a week behind.
You are. I've already given you a 0.
I'm sorry.
You're welcome.
I would like to do it on